Once a bridge is built, most of us assume that it will just keep standing. But these are finicky structures that demand attention. And some people literally must put their lives on the line.
Over.
Using the latest climbing gear, Jeff Finn and Richard Hunt rappel from the top of the bridge tower and check each part of the structure on the way down. The climbing team is part of an army of maintenance, repair, and inspection personnel assigned to each bridge. They are well aware of the consequences of missing even the smallest crack. In December 1967, cracks in a single steel eye-bar went undetected. Before long, these flaws brought down the Silver Bridge over the Ohio River in West Virginia. Changes in temperature weakened the eye-bar over time. No one was paying attention.
There were probably micro cracks in the eye bars. Those micro cracks became bigger cracks and caused an immediate failure of the bridge. And those are the kinds of things that might be picked up or should be picked up in inspections, certainly in modern inspections. Nobody can really predict accurately the speed of propagation of a crack. So one day it could be tiny, you come back a month later and it's much larger.
The collapse prompted the federal government to require regular bridge inspections. Now, every 2 years, each bridge over 20 feet long is examined and graded. Most modern bridges are made from a combination of high-strength steel and concrete reinforced with steel bars or threaded with steel cable. Scientists are finding new ways to strengthen them, but even the best man-made materials have limits.
Steel wants to revert back to its natural condition. It wants to corrode. That's its natural tendencies. In the Bay Area, we have a lot of salt in the air. The fog brings in salt, deposits it on the bridges, and you get an accumulation of that over years.
And as soon as that salt and the water and the debris are attached to the steel or somehow pawn on the steel, you get an electrolytic reaction, and the steel itself begins to consume itself. It's like a battery. Part of it's an anode, part of it is a cathode. You can actually measure the electricity on the bridge itself, and you could see that once there establishes a current, you're corroding that bridge. You're transferring steel into rust.
That's where the painters come in. From top to bottom, all year round, painters clean and coat every inch of steel.
One of the best set of eyes on this bridge is the paint crew. We rely very heavily on their expertise. They don't just come out here and slop paint on. They come out here, they look, they see something wrong, they give a call.
They're not the only ones keeping an eye on the bridge. Tow truck drivers patrol the bridge 24 hours a day. Electricians change an average of 2,000 light bulbs a year.
We have steel crew, we have concrete crews, we have carpenters. I'd say over 200 people.
This is what can happen when you turn your back on a bridge. Underneath the Williamsburg Bridge in New York City, mere bandages keep it standing.
We're standing under a 60-foot girder, and that girder should be in a straight line. It should look like the letter I. In fact, if you look at it carefully, it looks like the letter S. It's been struck a number of times. It's been poorly maintained. These wood posts are here, and what we have are wood posts that are supporting a steel bridge because there is no structural support for it.
As the former chief of New York's Traffic Bureau, engineer Sam Schwartz knows all about infrastructure. It's not just the Williamsburg Bridge that concerns him. Every year in the United States, an average of 150 to 200 bridge spans suffer partial or total collapse. Of the more than 500,000 bridges, as many as 1/3 require some sort of strengthening or repair. The total cost to fix these problems exceeds $70 billion.
I think when it comes to bridges, we are our own worst enemy. Bridges have a useful life just like we do. They get aches and pains just like we do. They exhibit many of the same things that we do. If we begin to think of them as human, and that there is a useful life to them, and in the case of some bridges, could be 1,000 years. We are often shortening that life to 50 years or 100 years, and that's unconscionable.